Okay, continue with some examples. Use logarithmic differentiation to find this. When we're using logarithmic differentiation, let me go back to our guidelines. We're going to have y equals f of x. We're going to take the natural log of both sides. We'll differentiate implicitly, take the derivative of each side, and then multiply by y. Okay, so just quick, give us an idea of what we're going to be doing. So the first thing we want to do is take the natural log of both sides. So it's just going to be natural log of y is equal to the natural log of, write that out. Okay, so once it's written out, now over here using properties, how can we rewrite these two? Using addition, and then we'll also do the power rule as well. So rewrite using your rules. Okay, so I did all of those rules at one time, and this is what we're working with. Now we want to take d dx of every term in the problem. So that's the next step. Take d dx of each term. Okay, good. So what is the derivative of the natural log of y? 1 over y dy dx. Good. Over here, we take the derivative. We just have this 3. And then we have 1 over 5x plus 2 times the derivative of the inside. What's the derivative of this term? Just 5. Good. Plus, now over here, we have that 2 times 1 over 6x plus 1. What's the derivative of that inside function using the chain rule? Just 6. Okay, so the next thing we want to do is simplify this. Okay, so we have that simplified. The next thing we need to do, to be able to get dy dx each side, what would I need to do here? Multiply by what? Y. Well, whatever you do to one side, if I just multiply this by y, you also have to multiply this side by y. This whole entire right side. So then that would leave us with dy dx, which we're looking for, is equal to, we have what we had in the brackets, times y. Well, what was our original y? Go back up. Our original y was this term. So at that point, we replace y this with our y that was given in the original. So it would be 5x plus 2 cubed times 6x plus 1 squared. Okay, so this would be our solution. If you went through and got a common denominator with everything and simplified it, you might also see this form as well. Okay, so we're going to still practice use logarithmic differentiation to find dy dx. Okay, first thing we want to do is rewrite this algebraically. Theta plus 3 to the 1/2 power. Okay, the next thing we do in each step is we're going to by our guidelines is take the natural log of both sides. So we'll take the natural log of both sides. So we have natural log of y and we have natural log of this entire thing. So let's be careful to make sure it's in a parenthesis. Now, because we can use properties of natural logs to rewrite here, this is product, so we can rewrite using addition, and then we have a power rule. So go ahead and use your properties of natural logs to be able to simplify this. Okay, once all that's simplified, what's our next step? Differentiate, but we're going to do dd theta because theta is our variable this time. So do dd theta of each of your terms. Okay, so let's calculate that. What's the dd theta times of the natural log of y? So 1 over y, but we have dy d theta, right? Okay, here we just have the 1/2. So we have our 1/2. 1 over, when we take the derivative of that, 1 over theta plus 3 times the derivative of our inside function. What's the derivative of this? Just 1. Good. Then we have plus. I left off a plus right there. The derivative of this is just going to be 1 over sine of theta times the derivative of this. What's the derivative of sine of theta? Cosine of theta. Okay, now let's see. We can probably clean this up a bit in just a second, but now my goal is to get dy d theta by itself. What do I multiply this by to get dy d theta by itself? Y. This is also in your properties, our guidelines, it tells us to do that. So we multiply the whole left side and the whole right side. Well, it works out nice over here, so we get dy d theta is equal to, I'm just going to have 1 over 2 theta plus 3. And then plus, this is going to be cosine over sine. So trig simplification here. What's cosine over sine? Cotangent theta. Okay. And then that's just times y. So y, we go back up to the original problem and we pull y. Y was the square root of theta plus 3 times the sine of theta. Okay, that should do it. Simplification of this, if you got that you may see. Actually, I'm not going to simplify it anymore. This term could be in the front of this term. Make sure you're aware of that it would be the same solution if this was in front of this term. So that should give you some examples to work with there.